today we have a little blast from the past, looking at some naming rules. And if you remember back to the ionic compounds naming section that we did last semester, whenever we were naming ionic compounds, we would just use the metal name and the anion name. And that's still how we're going to name all of the bases. So anything that has OH as its anion paired with any cation, that's a base by the Arrhenius definition. And so that's how we're going to name these. So you'll use that metal name plus the anion name, which is hydroxide for all of these. So just the same naming rules that you've always used for things that have OH. Now we have a note here that says some Bronsted-Lowry bases are anions, so we just use that anion name. So for example, maybe it's just, NO3. So this, we would just name it nitrate using that ion list. So reference those polyatomic ions on the list as needed. I will actually email out another copy of that polyatomic ion list because you will need it when naming this week, just in case you can't find it. So again, you would just name this as the anion name nitrate from the list. Or if it's a regular kind of element, like N-3, this one would be nitride. So that's how we will name the bases. The acid parts, up until this point, we would have just named the acids as hydrogen and then whatever the anion name was. So for example, like A, we would have just said this is hydrogen phosphate. However, when we are naming acids and talking about them, we're going to specify that they're acids, and so we're going to add a little bit of information here so that you can rightly name them as acids. It will always be a hydrogen paired with an anion, so we're going to look at that anion since it's going to be the only difference from acid to acid. And we're going to keep the root of that anion name, and we're just going to change it according to the ending of that anion. And so you have this little table here to help kind of guide your naming. So if the anion ends with 8, then you're going to change it to ic acid and keep that root. If it ends with ite, then you'll change it to us acid, again keep that root. And if it ends in ide, then it'll be hydro-ic acid, and that root goes in the blank. Let me show you a few examples of this, and then you will be naming acids in no time. So for number 1, it says for each acid, circle its anion ending, ide, ate, or ite, then name the substance or provide the chemical formula that goes with the name. So our first one, we have H3PO4. If you look at the list of polyatomic ions, you'll find that PO4, -3 charge, is phosphate. So we're going to circle 8. And that means we're going to use this ic acid ending, keeping the root of phosphate. So that would be phosp, and then ic acid. Chop off the 8 and then replace it with ic acid. So we got phosphic acid. The next one, we have the name. We're going to go back. So carbonic acid, if we see ic acid, that's telling us, hey, use carbonate. So every acid has H as the cation, and we just said this is carbonate. Again, look at your list if you need to. Refresh your memory. Carbonate is CO3 -2. And then use those crisscross method skills. This would make it H2CO3 for our carbonic acid. And again, up till this point, we would have probably just called this hydrogen carbonate. But now we are learning the acid rules for naming. Now we have hydroselenic acid. So we've got the hydroic acid ending, which pairs with ide. So we're looking for hydrogen paired with selenide. On your periodic table, you'll see it's in the column that is -2 charged ions. So then again, do your crisscross method and we get H2Se. That would be selenide. It's just a regular anion on the periodic table. Next we have HCl. Cl is our anion. That's a regular. So that one we would call it chloride. So that's an IDE. So our name here, we want the root chlor to go in that blank. So this would be hydrochloric acid. We've used this one a few times in lab, but we've always called it hydrogen chloride. Now we know this is actually hydrochloric acid, and it is a pretty strong corrosive acid that we've used in diluted form, so it's been relatively safe for us to use, but that is a common acid that we've used in lab. And our next two, we have HClO2. Looking up on the list, ClO2 is chlorite. So we've got ITE. So we'll change the ending ITE to OUS. Keep that root. So we got chlor. And then instead of ite, we're going to have chlorous acid. And then our last one, we have nitrous acid. OUS is telling it's an ite, always paired with hydrogen because it's an acid, and nitrite is NO2, -1. So our formula for this is HNO2. So there's our naming for acids. Bases, this should just be review because nothing is really different, just metal name from the periodic table and the name of your anion, which for a base will always be hydroxide. So LiOH, that one is lithium hydroxide. Next we have cesium hydroxide, and if we want to write this in the formula, it's always good to write its ions first so we can figure out their charges. Cesium is +1, hydroxide is -1, so this will be a 1-to-1 in our formula. CSOH. The rest are exactly the same, so the metal name, hydroxide, and then just use the crisscross method to correctly write those formulas. Number 3 and 4, I'm going to let you kind of fly on your own for these. So these are mixed acids and bases. So you're going to indicate whether it's an acid or a base based on if it has H or if it has OH, and then name it correctly. Then all of these, for number 4, again, indicate acid or base, and then write its ions in this second column, kind of like we've been doing on the side over here. Again, H will always be the cation for an acid, OH will always be the anion for a base, and then write the chemical formula using that crisscross method in the third column.